All right. So here we are. Okay, hey B, how you doing? How do you think you did? I hope you did well. For some reason, the sound isn't coming through on the video, and I'm not sure what. Oh, there we go. Here we are. Okay, hey B, how you doing? Okay, I had to make sure that it was straight on YouTube. So, okay, you feel pretty good. Okay, excellent, excellent, excellent. All right. So now we are now officially live on YouTube as well as TikTok. So I just want to make sure that we had everything that we needed for this lesson. Now, I just played a song as you guys were coming in. Oh, good. Random person. You passed AP Chemistry with a 5. Fantastic job. Fantastic. That is a very difficult feat, I do know, because so many students have talked about that all semester long. So congratulations, congratulations. Now, so what we're going to get into today, okay, all right. So you must be smarty art for real. Okay, okay, good, 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 good. So maybe you can give some tips and tricks to other people that you know who are going to be needing your assistance later, okay? Because that's not an easy thing to do. Congratulations, nevertheless. So today's lesson is going to deal with chemistry and BBLs. I'm going to actually go through some word problems to kind of explain this thing. You're probably saying, wait, what? We're going to do what? And why? Well, let me tell you, right now it's the summertime, and so many women are excited to get out and show off their curves, right? And some women have been working hard to develop it naturally. And then some women say they need some assistance to get that done. So, what I'm doing is showing the chemistry behind all of that fat displacement that they're taking from your gut to put it near your in your buttocks, okay? Your buttocks. So what we're going to do is we're going to discuss this, and I'm going to show you guys how density works along with that. Now, what you have to remember is that density, yes, it is the mass per volume of a substance, and that buoyancy relates to density based on the different substances. Now, in this case, you know that fat has a lower density than water. So when they take the fat out, and let's say they're putting it in a solution of water, then what they're going to do is acknowledge the fact that the fat is going to float. But if you take muscle out, on the other hand, you'll notice that muscle will actually sink, okay? Because muscle is more dense than fat. Now, this property is crucial during the separation process in liposuctions. Also, what you need to be aware of the fact is that techniques such as centrifusion relies on density differences in separating mixtures. Okay, so in a BBL, centrifugation, excuse me, is used to separate the fat from blood, oil, and other tissues after liposuction. So this purified fat is then re-injected into the buttocks, the gluteus maximus. Okay, and when you talk about viscosity, excuse me, which is a measure of the liquid's flow rate, this is where you have the viscosity of the fat that affects how easily it can be transferred through syringes and cannulas during the BBL procedure. So we have a whole lot of different things that we're going to actually get into tonight that deals with this whole concept, okay? Just FYI. So what I have here are some variations of problems that we're going to actually do, okay? And I want you guys to be on standby for those word problems because we're going to actually show you all how this whole process works, okay? When it comes to calculating these problems, and we did a little bit of this earlier today. So what I'm going to do is kind of go through some examples, and they're really easy. When it comes to density, though, density is not a hard formula to kind of process. It's not. Matter of fact, density just simply means the mass of a certain substance divided by the volume of a certain substance. Okay? The mass of a certain substance divided by the volume of a certain substance. So as I'm going through here, I'm going to actually give these problems, okay, so that you guys can actually see them and you can work them along with me, okay? So let me go ahead and pull up another part here, okay, that we're going to work on today. And I'm going to break these problems down for you so you'll know what to do, okay? So if you have questions, let me know. And if you can, tap that screen so that way I know that I am not just talking to myself, but that I do have participants that want to learn. So go ahead and tap the screen. And once we get to 1,000, we will start this lesson, okay? So once we get to 1,000, we will start the lesson. Hey, Chasney, how you doing? All right, so keep going. And make sure that you guys got your pens and papers as we go through this lesson, because what I'm going to also do is give you all some other tips on how to make these problems work, okay? So make sure that you guys continue to tap that screen, okay? I'm not asking for anything other than your fingertip to actually hit the button, hit the likes, okay? All right. I'm doing good. How are you doing? All right. So here we are right here. Okay. And what I'm doing, of course, is, of course, I am erasing the answer key so you don't see that part, because I'm going to actually explain this part to you. So that way you'll know exactly what we've got to do. Okay. So here in this first problem, it says, Dr. Alvarez needs to select the right cannula for Maritza's BBL procedure. She immerses a titanium cannula, which has a density of 4.5 grams per cubic meter, into a graduated cylinder containing 50 milliliters of water. The water level rises to 62 milliliters. So you're probably wondering, what do you have to do for this problem? Well, I'm going to show you the easy steps to do. This is called volume by displacement. Anytime you have a problem of this nature, all you have to do first is just determine what's actually in this graduated cylinder to begin. Right now, there's 50 milliliters of water in it. Then once you take the titanium cannula and you place it inside this graduated cylinder here, the water level is going to rise to 62 milliliters. Well, in order to determine how much volume was displaced, you have to subtract these two numbers. So when you say 62 minus 50, you're going to get 12, okay? 12 milliliters is your volume that was displaced. Now, since this is a solid, the units that are often associated with a solid when it comes to density are cubic centimeters, okay? Or you can also say, if you're talking about liquids and gases, those units are often liters, milliliters, deciliters, okay? So whenever you have a solid, that's typically a three-dimensional shape. So that's why the units here are cubic centimeters. But in essence, cubic centimeters is the same thing as milliliters. So your answer here is 12. So that's how you do the first problem, okay? That's how you do the first problem. Now, again, this is very simple because all you're doing is just subtracting. Now, suppose I ask you, well, what is the mass for this same instrument, this titanium cannula? Well, all you would have to do is take the formula, which is mass is equal to density times volume. Now, since we know that that is the formula, they gave you in this problem density for that instrument, which was 54.5 grams per cubic centimeters. You just calculate the volume, which is 12 cubic centimeters. And now all you have to do is cancel out your like terms, which are those cubic centimeters here. And that will give you to say, all right, well, 4.5 times 12 gives us 54. So 54 will be the mass of this instrument, 54. So it's roughly 2 ounces, okay, approximately 2 ounces. So 54 grams is that answer. Again, they did not ask you that, but just in case your teachers have a 2-part question where they're asking you to do multiple steps, this is the other thing that you could do, okay? Yeah, there you go. That's right, 54 grams. Now, here is another example right here. Again, I'm going to erase so that way you guys won't see how to do it, because I'm going to show you all how to do it from top to bottom, okay? And again, when it comes to these word problems, all you're doing is reading through what they're asking you to do. Look to see what numbers they've provided you in order to solve the problem. Okay, density problems are not difficult at all. Matter of fact, they're very simple. Okay, but you just have to read to know what they're asking you to do. Okay, so in this particular problem right here, it says, all right, well, you got a fat graft measurement. So what are you supposed to do in this case? Well, here we go. During the procedure, Dr. Alvarez extracted fat from Maritza's abdomen. She placed the fat in a container with 200 milliliters of saline solution, causing the water level to rise to 260 milliliters. So, you know, saline solution is nothing more but than a little bit of salt and water. Okay, so here you go. You've got 200 milliliters of saline solution that's already inside this particular container. Well, when you add that fat to it, okay, you know the fat's going to float, you know, because fat is less dense than muscle. The level of the waters or the saline solution is going to rise to 260 milliliters. Again, because this is a volume by displacement problem, if you're given 2 volume readings, all you have to do is subtract the 2 numbers, 260 minus 200, and that's going to give you 60 milliliters. Now, what do you have to do? That's it. 60 milliliters is the same thing as 60 cubic centimeters rather. Now, again, suppose they ask you to find the density. Well, you don't have anything else to help you with this problem. They did not give you the mass of the fat. They only gave you the volume that was displaced. However, I know that the mass of human fat is 0.90. So we're going to use that as our number, okay? So the density of human fat tissue is 0.90 grams per cubic centimeters. Now, if you are given the density and you are given the volume, you can use those 2 numbers to find the mass. So to find your mass, that's equal to density times volume, okay? So again, if you are given your density and your volume, you are simply looking for mass. So density times volume. So now you've got 0.90 grams per cubic centimeters times 60 cubic centimeters. And all you're going to do now, again, is multiply those 2 together. So you're going to say 0.90 times 60, and you get, again, 54 in this particular case as your mass. 54 grams. All right. Now, in this next problem, again, this is all based on a medical procedure. Okay, this is the one that I posted earlier about the density of the garment. Okay, the density of a garment. And you had several things that you needed to to look at and observe. So what I'm going to do, I'm going to actually skip this problem, but it's actually located on my page now. So you can actually go through this problem yourself, okay? And you can watch how I did it and to figure this answer out. So we're going to actually move on to the next problem right here, okay? And so you've got, again, let me erase the answer. Okay, there we go. All right, so here you were given a recovery drink. Now, you know, oftentimes, whenever one is finished with their procedures, they're going to give you a recovery drink to make sure you're fully hydrated. Now, if you are here, okay, what I want you to do is to go ahead and tap that screen. And once we get up to at least 1,000 hearts, guess what we're going to do? We're going to go ahead and do problem number 4. Okay, problem number 4.